Okay, this one's about velocity time graphs and also acceleration. So the objectives are you need to explain what is meant by acceleration and deceleration, recall and use the acceleration equation, another one to learn, be able to draw and interpret velocity time graphs, be able to calculate acceleration from velocity time graphs, and be able to calculate the distance travelled from a velocity time graph. Okay, on the spec is the equation for acceleration I'll be going through. Also talking about how you can get acceleration from the graphs. We'll be looking at examples of that. So the equation for acceleration is the change in velocity divided by the time taken. So change in velocity is measured in meters per second, time taken in seconds, and therefore the acceleration is meters per second per second. So it's a change in velocity, how many meters per second you change in a second. It's also often shortened to meters per second squared, as it's shown here. If you want to rearrange the equation, you can put it in the triangle where we've got two symbols for velocity now. We've got v and u. V is the final velocity and u is the initial velocity. So that's gives you the change in velocity. A for acceleration and t for time in seconds. Let's have a look at some examples then. You do need to learn this equation and use it. So here's some examples with some answers for you. A cyclist accelerates from 0 to 10 meters per second in 5 seconds. What is her acceleration? So you write down the equation you need. Acceleration is change in velocity with time taken. So it's 10 minus 0, start from 0, end up at 10. So change of 10 in 5 is an answer of 2 meters per second squared. That means that every second it changes the speed by 2 meters per second. If you work that out, in 5 seconds it would have gone from 0 to 10 meters per second. So that is correct. The ball is dropped and accelerates downwards at a rate of 10 meters per second squared for 12 seconds. How much will the ball's velocity change by? So you need to rearrange the equation in the triangle. V minus u equals a times t. So you assume it's dropped from rest, from 0, and therefore you work out v minus u is 10 times 12. It means it's travelled its new velocity is 120 meters per second. Number 3, a car accelerates from 10 to 20 meters per second in a time, with an acceleration of 2 meters per second squared. How long did it take? So you need the equation for time. Time would be change in speed or change in velocity over acceleration. The change in velocity would be from 10 to 20, so it would be 10. Divided by 2 would give you a time of 5 seconds. And finally, a rocket accelerates from 1,000 meters per second to 5,000 meters per second in 2 seconds. What is its acceleration? So straightforward equation, the change in velocity over time. Change in velocity here would be 4,000 in a time of 2. So it would be a massive number here, 2,000 meters per second squared. It's obviously a rocket has a very large acceleration. So just like the distance time graph video, I'm giving you a randomly drawn graph here so we can interpret it. Probably the best way to work out what these graphs mean. So the first section, you can see up the side we've got velocity, along the bottom we've got time. So in 10 seconds they change the velocity from 0 to 60. So straight line, diagonal line up means a uniform acceleration, means it goes up at a steady rate. Now a flat line, a horizontal line on a distance time graph meant stationary, but on here it actually means that it's going at a constant velocity. You can see that person or the car is traveling at a speed or velocity of 60 meters per second. But then this line here going up isn't going up at the same gradient, so it's still a uniform acceleration but a smaller acceleration. And now this one, a downward line going back, shows a deceleration. It shows going from 80 meters per second down to 0, down to rest again, so it's come to a stop. That's a deceleration or a negative acceleration. Acceleration is a vector quantity. You get a minus number, that means it's decelerating. So you might want to jot this down. Okay, so let's just do some working out. How fast was the object going after 10 seconds? Well, it was going 40 meters per second. What is the acceleration from 20 to 30? Well, its change in speed is 20. Does it in 10 seconds? 20 divided by 10 is 2 meters per second squared. What about the acceleration from 30 to 50? It changes from 60 down to 0. So it changes by minus 60 in a time of 20. So it's minus 3 meters per second squared. The minus number means it's slowing down. And so number 4, what is it? If you reworded the question, said what is its deceleration, then it would be plus 3 meters per second. Hopefully, second squared, sorry. I hope you can see what I'm trying to show you there. An acceleration of minus means it's a deceleration. Okay, now the harder thing to do is to work out the distance travelled from one of these graphs. So the distance travelled is actually the area under the graph. So if we want to work out the area under the graph for the first section, we can draw a triangle. That triangle, the area is half the base times the height. So in this section here, it will be half of 10 times 40, and that section travelling 200 meters. Then we can start drawing other rectangles and triangles. So this rectangle here is 20 by 40, so it's 800 meters. Then we can draw in this triangle, which is half base times height, half 10 times 20 is 100 meters. And the final triangle, to get the whole of the area, it's another triangle there, half 20 times 60. And then you add all those together, and the total area will be 1700 meters. This is a higher level skill that you should be able to do on a higher paper. You probably want to write this down. What about this one? Let's have a look at this one. This is Mr. T's journey to school. How far away does he live? Let's work it out. So that area there is 800, that area 1200, that area 200, and that area is 300. Add them all together and you get a total distance travelled of 2,500 meters. Hopefully this video has helped you to learn quite a difficult concept.